Have you ever gotten food poisoning and decided that it was your civic duty to immediately march down to your local public health office to alert them about a potential outbreak? Probably not, and nor is anybody else. My name is Charlie Chettleburgh, and my research aims to use all of our feces to reduce the frequency of food poisoning using wastewater surveillance. Only a fraction of the people who are infected by a foodborne pathogen are known to the public health department. Public health officials often struggle to estimate the burden of foodborne illnesses due to a wide range of symptoms and the fact that many foodborne pathogens are non-reportable. This means that even if people are sick enough to go see a doctor, they aren't always tested, and when they are, cases don't have to be reported to the public health department. While clinical testing provides information about who is infected with the pathogen, wastewater surveillance tests everybody in a region whose toilets feed into the sewage stream at a fraction of the cost. Any pathogen that exits your body through feces or urine can be monitored in this way. Wastewater surveillance detects changes in the prevalence of pathogens in communities to serve as an early warning system so public health officials can declare outbreaks sooner. 1 in 8 Canadians is affected by foodborne illness each year. These illnesses cause, on average, 14,000 national hospitalizations and cost Canadians $115 per capita per year. Hepatitis A, norovirus, rotavirus, and adenovirus are estimated to cause 66% of foodborne illness in Canada. These viruses all exit your body through bowel movements and are detectable in wastewater. Unfortunately, the infrastructure required to establish long-term sampling programs to monitor these foodborne viruses is difficult to maintain due to the cost, specialized equipment, and lack of trained personnel. The goal of my research is to establish sentinel sites in Guelph, Winnipeg, and Quebec City, Canada, that will serve as canaries in our community coal mine to limit the number of locations that need to be sampled for these viruses. To establish these sites, I am processing weekly wastewater samples over 2 years to compare the seasonal trends in the diversity and abundance of the viruses. I have also validated a new method that has minimal barriers so public health researchers and communities with less money will be able to collect data at a low cost. Pathogens are very dilute in wastewater, so samples must be concentrated to smaller volumes before testing. This new method is easy to do and requires little experience as it just uses a coffee K-cup and a 3D printed cartridge to concentrate the wastewater samples. 1 year into sampling, we estimate that using wastewater surveillance to monitor foodborne illness could reduce the time to declare an outbreak from 1 month to as little as 1 week by comparing viral detection to our baseline. Wastewater surveillance is another tool that we can use to combat contagious diseases and to prepare for a future with more unpredictability due to a changing climate and increasing population density. Thank you for listening.